your time in what is going to be not your typical OBI IDO session, I believe, because I had the privilege to work together with Niels and some other fine gentlemen from this room in the past years within the Arrowhead FPVM project, which I think has already been mentioned, and I might still be mentioning it a few times. But my background is somewhat different, and this talk, or I rather hope to think about the upcoming 50 minutes in terms of a get-together, getting to know each other, and a kind of discussion, because I think this is what matters. Anyways, my background is in model-based systems engineering, as you might have guessed from the title or from the topic. One of the very ambitious, but I think not too much overthought objectives or orientations of said FPVM project and its standardization working group was to study an alignment between study an alignment for industrial interoperability. So the overall aim of this is already given, but study it through an alignment between very different technologies, where on the one hand we would have IDO and upper ontology-based exchange in general, whatever the actual format is. And on the other hand, we would have model-based systems engineering, system models, and in particular, of course, listening to what's been going on in that community in the past years, we decided to focus on SysML version 2. So my assumption is that this is something which you might have heard about, because if somebody is working in with complex engineering life cycles from whatever perspective, then such engineers and researchers and managers and other stakeholders tend to hear about MBSE and SysML for that matter, but it might not be necessarily that well known what's actually happening right now. Where are we at with this? And what is the actual potential for these kinds of, inter-standard, inter-domain alignments, such as trying to somehow co-model certain engineering scenarios using ontologies, IDO, and system models, SysML together. So I thought that in the following, I'll basically show you two things. And these two things I kind of find very representative as a snapshot of where we are with this. So this is why I decided to just go this way. I'm basically trying to transport you to a conference, to a situation which I was part of a few weeks ago, where the OMG, the Object Management Group, had its last meeting. So first, I'm going to show you the SysML version 2 introduction slides from that session, which have not been authored by me. These are the official introduction slides coming from Sanford Friedenthal, better known as Sandy to many, who is kind of the father of SysML. We will start with SysML version 2 right away, but this will also have some information if you need even more context on that, where this comes from and why is it called SysML, etc. We'll have a few remarks on SysML version 1 as well, the earlier version. And then in the second half of the more frontal part of the session, which I don't want to have too long, we will see another presentation which has been held by some members of the Arrowhead FPVM project, showing how Arrowhead technology could be brought or transferred into a SysML version 2 compliant form. how this can contribute to standardization. And then, just to close this arc, at the very end, there will be a contribution coming from my team, which finally, as this was the goal all the time, explicitly started to experiment to set up a prototype which creates a bridge between ontology-based industrial information and corresponding system models. You'll even see a short moving demo, unfortunately not a live demo, but at least something moving and something happening at the very end. So this is the overall plan for the next couple of minutes. And yeah, let me just, I think at this point, go ahead and share some nice slides with you. So again, I'm assuming that a gentle introduction into SysML version 2 as such might be in place here. And oh yeah, this very meeting I'm mentioning now here in this slide, this is called the SysML version 2 summit. This was a very important point in time because the standard has been officially released. SysML version 2 is a standard. I haven't said that explicitly yet. Maintained by OMG, the Object Management Group, the same group who maintains UML, which is, yeah, has lost somewhat lost on its relevance, of course, in the past decades. But whoever is studying any kind of software engineering, UML is still their best known standard. And now on this meeting, a few months after publishing the standard, what we had was, I think, a key moment in time, because the standard is already out, and it's now that the community is not anymore just talking about some plans and some fanciful individual contributions, but now we are talking about the standard, which has to be carefully evaluated for its capacities, and also which has to be prepared for an industry rollout. So what is happening now is that OMG is starting to work on the next subversions of the standard, trying to address all the modeling or semantic shortcomings which have been observed since the release of the standard. And at the same time, they are also working together with INCOSI, the International Council of Systems Engineering, which is an international, community-based, non-profit, chapter-based, that is international, but then also localized at the same time, wherever there is local industry need. A fairly big organization for its kind, but it's not really creating products. It's really just a driver of discussions. And this organization in COSI, which is closer to industry than OMG itself, is now taking care of the industry rollout. But how this actually will look like, we'll have to really keep our eyes open in the coming month and observe what's happening with SysML version 2. Because, spoiler or disclaimer alert, I personally do not believe that the actual fate of SysML version 2 is decided yet. Releasing the standard was a huge achievement, but I think the industry impact, evaluating the industry impact and creating the best possible rollout plan is an even bigger challenge. And this is what's coming up. But this presentation and this discussion is not necessarily about these industry scale or organizational scale strategic and tactic developments. This is more about what SysML version 2 is. And I really thought that this is pretty much the best few slides right now to give you a gentle introduction into that. First of all, what is MBSE? I have already dropped the word MBSE a few times since I started talking, but we have not really visited the idea of MBSE itself yet. So MBSE is really, it's people often start pretty early in thinking, just somehow conflating or confusing MBSE with SysML. So MBSE would just, in many heads, be a synonym to SysML, meaning that this is a way to set up, as you see in the picture, diagrammatic models of systems. This is just one part of the story. MBSE is actually, it's a very vague term, I admit. Model-based systems engineering was that. It's more of a philosophy. One potential language to convey that philosophy is SysML. I think it's a valid thing to say that this is the most established way to talk about this philosophy. But MBSE is actually, if you just say that, it just advocates and fosters engineering processes and workflows which are flexible, interconnected, iterative, traceable, and lifecycle managed or governed. This is the essence. This is what it wants. And that's all pretty much there is to it. Of course, it's called model-based for a reason. MBSE claims that these desires can be best realized if you are thinking in terms of models. If you have a system model or a set of system models backing your engineering process, because that will then serve, as MBFC people so often say, that will serve as a connective tissue of your engineering endeavor. These are very big words, but what it actually boils down to is very often indeed, as you see on this intro slide, is a system diagram. A lot of, as Sandy also remarks, a lot of content here, a lot of hierarchy, a lot of embeddings. But this diagram in itself is, and this is what is very often an impediment of successful MBSE introduction, this is where it often stops. And if you stop here, then you really just got what people think, people often think that's all there is to it. What you have is a nice visual documentation, which is serves probably as a source for understanding, which might be a vehicle for discussion and communication about the system, but it's disconnected from other engineering disciplines, it's disconnected from the system itself, it's disconnected from the organization, and it's disconnected from the engineering procedure. Not traceable, in other words. So I basically already said all of this. One of the key organizations, the NASA Jet Propulsion Laboratory, behind this kind of thinking, the development of this philosophy, they represent it like that. They started to talk about already probably in the 90s about moving from a document-based approach on the left to a traceable kind of design thinking on the right, where everybody has a connective platform to rely on, all the different stakeholders, not just point-to-point connections, but something interconnected. I think you get the idea. Okay, what does it have to do with SysML version 2? Okay, this is very boring standardization information. But now we come to the actual sense of it. I think that much of a philosophical interaction was due. But let's take a step closer. Why was SysML version 2 needed? In my view, it was needed explicitly because of these aforementioned reasons, is that the very design and very implementation of SysML version 1 as a practical thing was drifting into this direction, that it was very easy to use it for a diagram first visual documentation vehicle, because these kinds of artifacts, of course, often tend to be a bit less approachable, a bit less interconnectable, and therefore, of course, interoperability is hampered already from the outset. And this is why a few years ago the idea of SysML version 2 came, enhancing MBSC with, of course, an update to SysML, a major update to SysML, but in what form exactly? These are the key elements. These are the three most important differentiating factors which we have to highlight here. First of all, SysML version 2's first original intention was to move away from being a dialect of UML, which was, of course, which is a language and standard designed at a very different stage of software engineering. And of course, if we are talking about systems engineering, that's kind of different from software engineering anyways. So they wanted to get rid of the UML baggage here, which they managed to do. We'll see in a minute exactly how, or yeah, at least roughly take a look at how. We'll have different kind of syntaxes. This is not what's written here, but that's the most. I mean, if you ask anybody who has heard about SysML v2 and might be able to guess what's the number one unique selling point, people would, I mean, 95% of people would say is the textual syntax. So yes, now you can not only draw, but you can also write system models. I would really want to discuss it in the last 10-15 minutes with you, if that really makes it more useful or not. But many people claim that it does. And another potential game changer here when it comes to MBSE adoption is that the API for accessing the models, for talking with them, for retrieving information, etc., is now also become standardized, which means that you don't always have to, reinvent the wheel if you want to have interconnected and traceable system models for your engineering, but you just have to look up the standard, how certain elements are looked up or queried or whatever, and there you have it already. So the language architecture looks like this. So instead of the original UML semantics and just kind of creating a dialect on top, SysML v2 decided to build the whole semantic baseline from scratch. This core semantic layer is called the kernel modeling language, short KML. So this is the bottom, the bigger box of all this. It's got, yeah, even that. So even within that, you have different layers. You have a core syntax and semantics. Notice that we are not talking about syntax semantics pairs all the time. And you have the core layer, and on top you have the kernel layer. I don't think we have to go into exact details of what the core and the kernel layer mean for each other. I think the only thing to remember from this is that the actual language, the systems modeling language, is built on top of this core semantic layer called KML. And again, I would like to at this point explicitly highlight or draw attention to the way domain semantics is handled in this setting, because for that you can build on top of a formally more or less grounded semantics, you can build your own domain model libraries. And this is what we actually, I mean, this capacity of the language is what we've been using when we built some specialization for FPVN. More on that later. Yeah, so these are kind of the the expectations towards such a language. Some of these aspects might be direct consequences of what I said before. We haven't been talking too much about behavioral models. That's also part of the story already with SysML version 1. Having structural and operational aspects side by side, kind of realized via complementing views. That has always been the idea with systems modeling. And another interesting note on that is that SysML version 2 is advocating this kind of reuse of elements by introducing a clean separation between defining an element in a certain comment. So this would be kind of the saying what it is. And then you have a very clean set of language extraction to express when this thing in itself, what it is put into a usage, put into a particular context where it's used for something. So a usage would be the spot where you describe what it does. It's a good pattern. I believe it's still kind of the one of the parts of modeling with SysML, or one of the aspects of modeling with SysML, where you really have to just get the feel of it. It's not very, it sounds good, but it's not always very clear how to cleanly implement such a pattern. Yeah, we don't have to go into this because this is only for people who have been already well versed in SysML version 1, just wanting to understand what would be the corresponding keywords in SysML version 2. There has been some renaming, as you see, but not too much. So even though it's still not fully clear, yeah, questions like that often come up. So there's no straightforward way to just migrate a SysML version 1 model to a SysML version 2. The mapping is still, so there still exists a kind of a logical mapping between the two. This is not interesting for us. So now here, I think better here, we finally see how this actually looks like. So as I already said, the idea here is really to have the graphical representation, the diagram representation, and the textual representation as just two equivalent, semantically equivalent representations of the same system model, having them all the time side by side, none of them, at least ideally, dominating the other. These are just two concrete syntaxes over the same single abstract syntax, which is defined via caramel. But to look at it more practically, like what would this mean for us? This is of course a very deliberate, simple example of how to start modeling certain parts of a vehicle. Of course, you have to define a part. Notice that this is a definition of a part, which is a vehicle. So I'm trying to say what a vehicle is. A vehicle has an attribute mass. Of course it has a mass because we are living on Earth. It can perform certain actions. It has certain paths. So you see a simple embedding. An embedding can be expressed very clearly in graphical as well as in textual terms, right? So this is actually usual practice, I would say. And yeah, then here we go on with further attributes and further actions and a connection between the two. So this is actually, to those of you who have seen a few SysML version 1 models maybe earlier, this is a bit different. So you're not using things like proxy ports and interface definitions and all the likes. I mean, at least not in that form before. Here in this simple example, it's a very clean thing. If you want to get some some information. Here it's a talk through some output to another import, taking that in. Then you just write connect, and there you have it. And then yes, it's also operational, so actions can be actions also have their own syntax and their own way of expressing them, both graphically and both textually. So this was just an example. And yeah, for the last aspect before we switch to the alignment material, I mentioned that this is very important. I just wanted to highlight this again. I personally do think that it's a very important and actually a quite big achievement. It's a very good intention and a big achievement that is there. Having the SysML version 2 API there in the standard means that whatever tool from whatever domain you might want to connect with your central system model repository, you can be 100% sure that you're not creating a further disconnect. You're not creating just yet another silo by extracting data and shaping it or storing it based on your own liking, because the API is really making it sure that you're really getting your silos interconnected and you're creating a digital thread. So I think it's super important. These are just the marketing slides at the end, but I think we have touched on most of these aspects for now. So without further ado, I think I'll just move you to what we actually started to do with this emerging base technology within the Arrowhead FPVM project. Let me just share the corresponding slides with you. Let me see if I managed to make them full screen. Excellent. So yes, this was part of the very same meeting. I mean, this presentation pretty much came up not much later than the original introduction slides I've shown you before. And this was planned and this was important because this is the first kind of collaboration where we started talking about within our project and now external with OMG about making a domain library as a domain-specific extension part of the standardized set of examples. So of course they've been planning for that, but Arrowhead as such could become an early adopter. Now, unfortunately, I don't know. I was not there at all the presentations, and I'm not sure if this was on the agenda. So I'm not sure how much I have to introduce the principles of Arrowhead. I don't want to spend too much time on that because my time is running out. I would rather try to focus on the actual potentials of an ideal alignment, because this is what we are partly or even mainly here for. That's why we are sitting here for together. Feel free to ask later questions if I would rush through the Arrowhead principles too quickly, and therefore if it's not becoming really, or at least if it's not becoming clear at all what am I talking about, what's behind this, what kind of systems are behind this, then just feel free to ask later. We'll open the Q&A soon anyway, and I'm really looking forward to that. But let me just walk you through here quickly. Why is this important and how we approach this? So as there's this feeling you might have developed already that even though SysML version 2 is a fresh start, all the discussions around SysML version 2 somehow start with, okay, how do we differentiate ourselves from SysML version 1? And this is not any different for Arrowhead as a series of projects, because in an earlier installment of Arrowhead, notably the Arrowhead Tools project, which ended a few years ago, 3 years ago, I believe, maybe 4, the de facto systems modeling baseline language, actually many years ago suggested by me that we should give it a try, was SysML version 1. SysML version 2 was not yet around. By the time we started to write papers about this, the very, very early, very rough specification prototypes of SysML version 2 started to emerge. Therefore, a few years ago, 2 years ago actually, I thought it was more, we had a paper out already which had ideas for a SysML version 2 library, as opposed to the DSR profile we've been using earlier. So notice that even the terminology was changing between 1 and 2. So a domain extension would be called a profile in SysML version 1. By the way, SysML version 1 itself was also a profile of UML. So that's kind of, you can stack this concept. You can also stack libraries, but now the extension concept, I think it's much more convenient and straightforward nowadays. With SysML version 2, it's called a library. So what we are building a library for, and this is what I'm not going into to any considerable detail, is this Arrowhead technology stack, which has many different systems. Some of them are core for an Arrowhead. Okay, so if you have not heard that even before, Arrowhead is kind of an orchestration platform to deploy system of systems. And the platform itself has some core systems which take care of the orchestration, the registration of new devices and new systems, and their services is service-oriented. So it's a service-oriented system of systems orchestration framework. That's what Arrowhead is. And we started to represent the core technology itself using SysML version 1. This was the Arrowhead domain-specific language, which is basically, technically, now we understand each other, a SysML profile. Of course, it has a bit more. It has a touch already, which is very right. If you remember my introduction, it also had an aspect of lifecycle management. So you could also represent steps of engineering processes, for example. So SysML tends to become tends to be used on high abstraction levels, right? Anyway, so actually configuring engineering processes and tool chains is a very convenient thing to do using SysML. I think this will also be valid for SysML version 2, even though these use cases for SysML version 2, at least to my knowledge, still yet have to emerge, so to say. This is just a kind of a very quick, a very rough visual impression for you on how the Arrowhead technology can be represented using SysML version 1. This is a tool called Papyrus, developed in France at the state-funded research agency CEA. They have a UML and SysML modeling tool, Papyrus, and which of course you can customize even as an external developer because it's open source, but of course the developers themselves can do it very quickly. So this at some point has enjoyed, or still enjoys actually, a customized Arrowhead modeling palette. Not necessarily going into version 1 details right now. This is the version 2 library. This is not what I would like to spend the last few minutes with. I'd like to show you this, what we actually did. So what's happening here, we already started to take one of the use cases, one of the industrial use cases in the project, in the Arrowhead FPVM project, coming from data exchange in the process industry, which is kind of a specification for the process industry on how to kind of formalize exchange of certain information. Here, in this case, piping and instrumentation diagrams between use cases and engineering scenarios, which is actually, as you see here, just a kind of as an appetizer, which you can express in Arrowhead terminology pretty well, and that terminology also lends itself to a very nice SysML version 2 representation. Therefore, we decided to use this context. We take it as a context, and we try to understand what's actually happening between SysML version 2 and IDO. And maybe STEP later on. I also indicated STEP here as another ISO standard, which is very relevant for Arrowhead, which we didn't end up doing too much interaction with. But we did a lot of interaction between IDO and SysML version 2, realizing that this can be a very nice co-modeling setup for traceability and lifecycle management, because the language stacks are complementing each other pretty well. None of the layers on each side are exactly aligned when it comes to semantic abstraction. And therefore, you can build up kind of a very nice semantic ladder if you're using SysML and IDO next to each other. I think this is we could go into extremely fine details of this, but as a takeaway, I think this is what's important to remember. And it's also nice to say that if you look at all the things which have been already built based on ontologies and ontology-based analysis or analytics for Arrowhead, look at IDO being featured here and DexP being featured here. You can kind of very nicely map it into different layers of the Arrowhead SysML version 2 usage, starting from the basic library, which you have seen a glimpse of, to specializing it for domains. Again, libraries can be stacked or can be further specialized. So specializations can be chained, right? So this is the essence, and so on and so forth. And this is what we are trying to promote a little bit, this thinking within OMG. And an interesting and I think very timely experiment which we've been running on top of this idea, and this is where I come to the before the discussion, the final kind of where we stand with this thinking right now. We wanted to have an LLM-based, AI-based experiment if we are able to take this SysML Arrowhead semantic space and somehow try to map it to IDO, acknowledging that the logic or the semantic thinking behind these engineering realms is somewhat different. You have to deal with inconsistencies coming not from just missing data or something like that, but from different abstraction levels, different kind of reasoning logic, where MBSE would more advocate a kind of a validation and verification based, kind of closed word validation semantics, whereas something like IDO or any approach would take you into a kind of an inference-based thinking, where you would want to expand your knowledge in an open world. This is not necessarily what the system model is for. But still, what we wanted to look at, if these words can somehow still be aligned, and if we can set up a practical and not just a theoretical scenario where these things come together. Sorry, the main shortcoming of this video, it's that it's showing a full high resolution screen and it's never zooming in. So I hope you can lean close and at least roughly see what's going on. So what we see here is an Eclipse, workspace with an arrowhead example model inside. It's a DXP model, so it's really it's a sample model indeed. It's a toy model if you wish, but it has all the typical elements which are used in a process side industry piping diagram. What you see now is that we've switched from the basic design description. This is already our terminology. We have switched to a usage of the parts which we have defined before. So here a reactor is already put into usage. You see it's a process plant, which is the context for that usage, and we are using our predefined blocks, like for example, flow regulator, controller, reactor. Of course, I don't know exactly what these things are, as I'm a computer scientist and not a chemical engineer. But that's the nice thing about MBS. I don't really have to know. I just have to know that I have blocks which somehow want to be interconnected, and my language gives me the power to interconnect them. Of course, this thinking is not very alien to ontologies as well, and this is why we decided, okay, let's see, what if we take that kind of model and try to transport it into an IDO ontology-based description. And this is what's happening. So with the help of an LLM transformer, we actually managed to create a representation which can be parsed with Protégé, and where you see the reactor design description, so the reactor DD you've been seeing before, is there, and the AI is even giving you, some kind of suggestions for potential alignments. And this is the good thing between IDO-based classes and some elements coming from your model. So even though the system model has a different logic behind and has been coming from a different engineering space, it seems that it really makes sense to reason about the meaning of those elements in an IDO-based setting. And even though I'm not a domain expert, as I said in the very beginning, I feel that being able to parse and query and observe these kind of ontology-based representations of an actual system of systems in both realms at once is a very interesting way to go. So this is as far as we got in the Arrowhead FPVM project with this line of work, and this is as far as I get today with my presentation. So having filled my 45 minutes and having 10 minutes left, I would really love to open the space for discussion here.
I cannot see any questions in the chat, so please go ahead and just ask questions for Géza.
Yeah, sure. Yeah, just feel free to speak up.
Hi, great presentation, thanks. I have, I guess, two questions. The first is, so is there a systematic conversion from SysML to ontologies, or you guys are still experimenting and doing it piecemeal with LLMs?
Sorry, what was the beginning of the questions? If there is a
systematic conversion, like almost a standardized thing.
No. We actually, I mean, of course, it's a very logical question to ask, and thanks for asking that.